human is weak. Right. So if we talk about symptoms, I think most of you might have heard the news and know the symptoms already. It's a really common like list of symptoms. It can be very easily misunderstood as well, because as I told you earlier, coronavirus has been there for thousands and thousands of years. Even there are few coronaviruses which will cause common cold. Since they have been there for thousands of years, our bodies, our ancestors bodies have generated some reaction for those viruses, and it won't go far further than 3 days or 4 days. It will be a viral fever and it will go away. But this is something new. Our bodies have to identify this virus and create antibodies from scratch, because there's no genetic information about this virus whatsoever. So we will get the normal symptoms of a coronavirus at first. What are those things? Fever, fatigue, and dry cough. Why dry cough, you might ask? Okay, this is a very important symptom, because fever and fatigue, we we can have fever and fatigue any day, right? Because fever is a very common defense mechanism that our bodies have whenever we have like any sort of invasion, like bacteria, virus, worms, any sort of invasion. The first defense mechanism the body goes to is fever, raising the temperature up to some level to mitigate the actions of these viruses, because most viruses and bacteria, they don't like heat. They active in like a precise temperature around 30 to 36 temperature, and it goes beyond that, they will slowly get down into a sleeping state, and it will still work, but the frequency of spreading will slow down. So fever first, and fatigue. There will be fatigue because of the effects of this our immune system triggering up, and then of course we will have fatigue because of this fever condition as well. And dry cough, this is important. Why dry cough? Because as I told you earlier, we get this what you call we get this virus through our uh, respiratory system. So somebody else comes to close contact to us. When they cough, some droplets of saliva or snot can come across and then can land in our body, sometimes hand, sometimes face, and there's a possibility of that going through into our respiratory system. What is the first entrance of the respiratory system? It is our mouth and our nose, and both of these will get together in the nasopharyngeal area, like here. Both these cavities will connect, and it will go to our through our throat, it will go to our lungs through this wind canal. So these viruses normally connect to ACE receptacles. So we have some cells in our upper respiratory area, in our throat, with ACE receptacles. So virus will first attack to those areas, and virus will start to what? It start to spread firstly in that throat and nose, like inner nose area, the nasopharyngeal area. The virus will first thrive in that region. That's why we get a dry cough, because the virus will thrive in that region. It will use up all the healthy good cells for its own good, and it will multiply, and it will cause inflammation. Inflammation is one of the immune reactions that we have whenever our immune system attacks a virus. When it attacks the virus, it will create some like like war-like regions with inflammation, and it will release some chemicals. It will release if if the immune system has antigen already, if the immune system has the information of an antigen, it will release the antigen. Antigen is like a poison to the viruses. So because of this battle between the virus and the immune system, you will get inflammation in that region, and it will dry out all the saliva in that region, and it will trigger a cough even, because it's uncomfortable for that region, and will our respiratory system has like a reflex of whenever we have like something troubling in that region, our body's reaction is generating cough. So we will have a cough, and that cough will be dry because of that inflammation in the region. And what is the next step? The next step is the virus will start to go down the system, because the last stop of the virus will be the lungs. So whenever we have the lung problems, we will get the shortness of breath. So this aches and pains, runny nose, because that doesn't happen to all the people. Some people might have different sort of histamine reactions. So histamine reaction is another reaction that the body has whenever it's under attack from some other organism. So I think you can see my view, right? Right. Okay. So the symptoms, the other symptoms will be shortness of breath, because this is mostly a secondary symptom, but some people can get this symptoms so fast as well, because they have received a huge viral dose from a carrier, and then that viral dose can travel directly to their lungs, and then it can be affected from the lungs to up. So they can get a shortness of breath, as well as diarrhea. Remember, I told you that some of the ACE receptacles can be found in the digestion system. So if the virus goes to there through the blood system, or some other bodily fluid system, it can travel to this region as well, and then it can give you a diarrhea as well. There are some rare cases of having some effects on heart and brain as well, but this is not I have seen some chats here. Is it something troubling in my presentation, doctor?
No. These questions I will raise at the end of your presentation. I requested people to raise their questions on the chat box without disturbing your presentation.
All right, okay. Because I thought that there's something some people can't see or something like that.
No.
Okay, I'll start then.
Yeah.
So you can see some statistics here because numbers play a big role when we are identifying a disease, a new disease like this, especially during a pandemic situation. Numbers play a huge role. Some place that we can help as well, because engineers are good at numbers, we are good at modeling, we are good at like creating information from raw data. So as you can see here, fever, dry cough, and fatigue are the main three symptoms that we can see in a COVID positive patient. And some people will display shortness of breath and muscle and joint pain as well. So I will go through what will happen in the lungs, because this is what killing people, right? So shortness of breath, and then finally we call that ARDS, acute respiratory disease syndrome. Yes. So ARDS will trigger in, and then the the humans will stop breathing by themselves. So that's the point, that we need a ventilator to support the breathing from outside. Right. So this is a healthy lung. You can see the nose, the mouth, the nasopharyngeal area. This is the area that the nose and mouth connects together, and the windpipe, and it will branch out into two lungs. So lung itself, it's not like a balloon. It's more like a sponge. You can see the branching happens more and more, and at the end you can see a structure, something like this, alveoli we call it. So this is the area that the oxygen transformation will happen. So the lungs will bring oxygen rich air into alveoli, and you can see these small blood veins are coming and going from alveoli. So the red one is oxygen rich blood, and the blue one is carbon dioxide rich blood, the blood without much oxygen. So this blue blood will come, it goes around, this one is wraps around the alveoli like this, and the handing over happens in this membrane, this tissue. Handing over will happen, and the oxygen will enter the bloodstream, and carbon dioxide will exit the bloodstream. That will happen in the red blood cells. As we know, the chemical called hemoglobin will receive the oxygen and make a compound, and then it will travel back to the heart, and it will pump the oxygen rich blood back to the body. So that's the normal gas exchange happens in a healthy alveolus. So this is a healthy alveolus. You can see here, it's more like a balloon with a thin outer frame, a thin membrane, and this membrane contains Y receptacles, the ACE receptacles, right? So what will happen if a COVID virus enters into this cavity, into this alveoli cavity? It will attack these ACE receptacles inside the alveoli. And what will happen? First, it will attack and reproduce the viruses, and these new viruses will attack again, and within a day or two, it will completely attack the insides of your alveoli. So if you take one alveoli, it will call alveolus. You can see here some fluid is building up. What is this fluid? This is because of the fight between the white blood cells, the defense mechanism of our body, and the virus. So how this defense mechanism is triggered? As I told you earlier, when the cells are dying from something, these cells will send a signal to our immune system, and the immune system will seep into that area to fight off whatever the foreign body it has inside that. So the best mechanism, the defense mechanism is it will eat the virus. The big white blood cells will try to eat the virus. If that is not enough, the white blood cells will emit some chemicals. These chemicals are harmful for living cells. So the virus will die as well as some of the healthy cells will die as well. So when the cells are dying, all the material in these cells will seep out. So that material is these fluids, cellular fluids will be there. So, and you will get inflammation as well because of this fight. You will get like a inflammatory reaction will be there as well. So this is a moderate reaction to the virus. As you can see here, almost half of this alveolus is filled up. If you take an alveolus as well, almost half of these alveolus are filled up with fluid. So what will happen? This gas chambers filled with fluids. The amount you have to fill gas, the amount you have to do the gas exchange will be reduced. That's why we get the labored breathing. And the next stage is this. It's completely filled out with protein rich fluid which came out from the dead cells and dead viruses and dead white blood cells, and it will destroy the surface of the alveolus as well. That's a damaged lung, and that damage cannot be repaired in a typical human lung. So that's why some doctors tell that the virus can give you permanent lung damage in the long run. That is true because these things happen. So here I will show you some other two organ damages as well. The brain, you can see here in the arrows, there are some inflammation in the brain. This is still in the discussion area because doctors are not so sure is it caused by the coronavirus itself or some reaction to it, which is done by our body, and is it recoverable, is it not, because we can't tell because it's just an year it has been since we had this new virus. We need time to make like a educational decision. So here you can see the heart. Even the heart tissue can be inflamed because of this immune reaction of the body. You can see the rooms inside the 4 rooms inside the heart is getting smaller and smaller, and eventually if you have like blood clotting, that's another region that we have to talk, because the COVID can trigger blood clotting. The doctors are still doing some research on that because they are not so sure is it the coronavirus or something else. So you can see when they have done autopsies in these dead people, they have seen huge blood clots everywhere in the body, and that could be caused by coronavirus. We are not so sure. So blood clot is another dangerous side effect of coronavirus, which can damage organ, and eventually it can drive a human being into death. And this is something some people have seen. They call it COVID toe, some tissue damage in the toe region, because the doctors have identified there are some ACE receptacles lodged in these small blood vessels inside your fingers, and these small blood vessels start to inflammate because of the coronavirus attack, and then you can have this red rash in your legs as a result of this coronavirus attack. So the medical care, it's really versatile at this moment, because it all started with respiratory aids. First, the patient will given some oxygen, and then in the acute levels, the patient will be taken to an ICU and given special breathing aid using a ventilator. But now doctors have identified, if you can identify a corona patient early in the infectious cycle, they can give some medical to fight some medicines to fight against the coronavirus, and then they can stop the virus from going into that critical stages. So and again, as I told you earlier, they have identified some blood clotting in the patient, and nowadays some doctors they prescribe some blood thinners into the treatment plan as well. So the treatment is not certain at this moment. Doctors are still trying different approaches, but I think they are doing something right, because if you see the mortality rates, not here in Sri Lanka but throughout the world, it's dropping, right? Even though you can see the number of patients are going up, you can see the mortality percentage is somewhat going down. That means the doctors are doing something right in this medical care region of the COVID pandemic, which is really good. So test and diagnostics. So this I will go through quickly because this is hugely biomechanics, and like you need to know a lot about uh, biochemistry to understand, but I will go through the basics of it. So as I told you earlier, the first place you can find coronavirus lodged in a positive corona positive patient is this area, the nasopharyngeal area. Some people might ask, okay, why you have to put that thing so deep into your nose? Because that's the place you have the most ACE receptacles in your nasopharyngeal area, so that this tab need to reach that region. Otherwise, if somebody do like a weak penetration here, maybe he won't collect any virus at all, and it will give a negative PCR test, and you can and the doctors might think, okay, you don't have virus in your body, and you will be released into the society. It's a very dangerous situation. So that's why they try to reach the actually it's the well bottom of the nasopharyngeal cavity, and they can have this corona positive sample if the patient is corona positive. So what will happen here, I will quickly go through. There are three main steps in a PCR test, and it all uh, related to temperature differences. So what it will do first is it has to, so what is PCR actually? It's a polymerase chain reaction. What is a chain reaction? It's something happening continuously so fast. So from a swab, like a single sampling of a patient, you can take some corona viruses into your cotton swab, and that hello hello so you can only get some number of viruses into your sample, but that number of viruses is not enough to make a good decision about is this one is having this sample is having coronavirus or not. We have to multiply that number. So the PCR process will do just that, multiplying the number of viral DNA that you have in the sample. So you have, let's say you have one strand of viral DNA in your viral RNA in your PCR sample, and it will go through a denaturing process. It will heat up and it will break down this RNA into two parts, and then uh, this one is called priming, and it will use a primer to identify the end points of the dislodged RNA, and that part is called annealing, and it will find out the ends. Now it's this one is, it's not this simple. It's inside a test tube mixed with so many chemicals. It's really difficult to identify the viral RNA apart from the other things if you don't have a primer like mixed into the this cocktail of chemicals. So then it will do is extension. This extension part is done by a polymerase, a DNA polymerase. That's why this test is called polymerase chain reaction. This special polymerase have the ability to fill the gaps. So here you can see it's one half of a DNA and another half of a DNA, and this polymerase can fill the other half. It's like raw material. You have a half of a plant here, half of a plant there, and the raw material will fill the other half of the plant. So now what you have here, first you had only one DNA, and now you have two DNAs at your disposal. So it has been doubled. The same process will be repeated for 30 times. So what will happen? It will denature, anneal, and then complete the copy over and over and over for 30 or more times. So what will happen there? So one DNA will become 2, and 2 will become 4, and 4 will become 8. Like that, 2 into the power 30 copies will generate in 30 cycles. So 30 cycles is the norm that we normally use for corona testing. So 30 times the corona will be multiplied, and you have a rich enough corona sample in your disposal after this process of polymerase chain reaction. So this is the machine. That it is a simple lab machine. Some machines are really complex, even a simple lab machine to do this chain reaction in the lab. So this is basically what PCR method is. And the other one is, this is somewhat new to this corona battle, the rapid antigen detection test. This is not so accurate, maybe some can say, as the PCR, because PCR positive, it means PCR positive. There's no going around it. Negative can be a little bit tricky, because as I told you, sometimes the doctors won't hit the right place that the patient have the coronavirus lodged in their throat. So you may have a negative result, but there's a 30% of you being positive while you're getting a negative result. That's why the doctors encourage to do test after test, at least 3 tests to confirm that you don't have coronavirus if you have like close contacts to a positive patient. So rapid antigen detection test will tell you that you have antigen generated in your body because of a COVID-19 virus. So that's it's very simple. Like, it's a very simple blood test, just like a pregnancy test. It will tell you if you are positive or a negative. There are a lot of discussion going on this test method. Some say it's not reliable, and some say it's the most reliable thing at the moment, rather than doing PCR. So there's a big discussion going on. There's a lot of debate in the topic of using this as the primary test for coronavirus. But at the moment, I'm not sure it's going to work or not. We'll see in the future. So why it is a pandemic? This is something that we have to talk a little bit as well. So as you can remember, Sri Lanka had this virus few months ago, which was not deadly. We never had this much of spread across the country. Even though we had a Navy cluster, it was well contained. We knew exactly what's going to happen to the patient, and the mortality rates were so low. But the second wave, somewhat difficult, right? It's somewhat dangerous. So what happened? So the second wave has been so infectious because the virus has developed a little bit. As you can see here, the virus, there has been little changes in these spikes, the antenna. Remember, I told you the antennas which connect to the human cells, they have somewhat developed into being so effective in connecting to human bodies and exploiting the human cell to generate the new virus strands. So we called it, it's actually used, it has been 2-step process. First it has to connect, then this virus then this antenna has to open up to release the DNA inside. But now this new strand of COVID virus has this antenna already primed, so it can just connect and release at the same time. So it has reduced 1 step of infecting people, and that's why the virulity of the virus has gone up. So in the right, you can see the new strand, the new version of the protein spike that you have in a coronavirus. So here you can see the spread of the virus. The different strand is another problem of this coronavirus. The reason it has gone to be a pandemic, because of the new spike, it has multiplied the ability of like infecting people, and then the other thing is it has developed different strand in different region of the world. So you can't go for a single cure at this moment. So you can't have a single vaccine at this moment because of this mutations and having different strands in different regions of the world. So another thing is, another important thing about coronavirus is it infect your throat first, right? So you have like millions of viruses lodged in your throat area. So what will happen if you talk and sneeze? This can easily go out into the world and it can affect almost all the people around you. So that's another thing to enhance coronavirus as a pandemic triggering virus. So this is some information about the 3 strands. This is somewhat old news because this was back in April, but now there have been multiple strands, and these are the main 3 strands. A being the primary strand, which was identified in bats even, and then the type B is what which has identified around the Wuhan area, and type C is the daughter of type B. That means the mutation of type B, and that's what spread across Europe, making a havoc. And the timing, this is really important as well, something we normally don't think so much about. So when the virus triggered in Wuhan, it was December 2019. That was almost the time for Chinese New Year. So a lot of people from around the world came to China to celebrate this New Year with their family and loved ones. And then they all went out within a month January, and most probably with virus in their system. So it's one of the most effective globalized virus spread that we had in the near future, because of this influx and going out of tourists and Chinese tourists for Chinese New Year and back to their like work or studies or whatever to other countries. So that's another thing which triggered COVID as a pandemic. So cure and immunity. Cure, I'm not going to give you like specifics at this moment, because it's still going. It's still the vaccines are still going through the testing phase. But there are 2 main vaccines. One is using the coronavirus and making it ineffective in the RNA phase, and then injecting this diluted type of this broken down type of virus into humans, and then triggering the human immunity system to make antibodies in the system. And then whenever the real virus enters the system, it can attack the antibodies that we have already created in our bodies, can attack this the real virus and destroy it before it causing any trouble. That is one approach. The other approach is really new. I think it's that that vaccine is the first of its type that some scientists in UK, they are the pioneers on this drug, have identified a way to create this you remember the protein spikes of the virus, right? They have create a way to generate these protein spikes in the lab, and they are trying to inject this only the protein spikes, not the whole virus, into the system, into our bodies. And these protein spikes will attack our healthy cells, and it will trigger immune response to make antibodies for these spikes. So if you have antibodies for these spikes, then when the real virus comes into the system, it will attack these protein spikes, the antennas of the coronavirus, and it will nullify the effects of the virus entirely. The virus can't live for much long in the body without multiplying, so it will die out, and there will be no problem for us as humans. So until that happens, we still in danger. We still have the possibility of getting the virus, and the virus is mutating. So please be careful, because until the vaccine is out, even the vaccine is out, we don't know the negative effects of the virus, the vaccines, because these are brand new viruses. And since the pandemic is raging through the world, sometimes the authorities, the people who are authorizing these vaccines will give out the vaccine to the public in a little bit of rush, and that might give some long lasting issues, but they are making they are trying to make it possible. uh, eh, I think from the news that I heard, I think the first quarter of the next year, within the first quarter of the next year, they are going to release some vaccines into the public. Since this vaccine is going to be injected into healthy human beings, it's not like a cancer vaccine. Cancer vaccine uh, can be in the research phase, and still the doctors can inject that vaccine into patients because the patient is already dying. You can try anything, but this vaccine will be injected into healthy human beings. So the scientists know that, the doctors know that. That's why they are doing this vigorous testing, because they want to make sure this vaccine is going to be okay if it's entered into a healthy human being. So that's the story behind the vaccine for COVID-19. And the social responsibility is really high. I will just give you the numbers. So here are some contagious viruses that we have in the society. So as you can see here, measles, smallpox, polio, those things are highly contagious compared to COVID. COVID is in the bottom right here. So what is this number? This number is really important as well. This number is called reproduction number. So what it means, let's say I will take measles as an example. If you have measles, if you contact 12 people, there's a if you contact some society without protection, you can give the virus to 12 to 18 people in a single interaction, and smallpox 5. And COVID is around 1.4 to 2.5 people. This is a huge number, just like the PCR DNA extraction. So let's think I have virus in my system. I'm giving it to 2.5 people in a close encounter without using any protection, and these people can give it to another 2.5 into 2 number of people. So it's into 2.5 to the power of n. That's the cycle it will go. So it's a huge number. After it's almost like 1500 people after 8 encounters. So it's a huge number. Only way we can reduce that number is by using protection. So this 1.5 number is when you're using masks and using social distancing. And you can, only way you can reduce that number beyond 1. So if you can reduce this reproduction number beyond 1, if you can go for 0 point something, that means you can contain this virus without spreading. If it goes beyond 1, that is the area that you are spreading the virus into the society. So the only way right now we can get this number beyond 0, beyond 1, it's like below 1, is by doing a partial lockdowns in the affected areas. There's no other way. So we have, at the moment, we have to tolerate these lockdowns, because that's the only way we can stop the virus from spreading into new areas, new people, and making a lot of people sick at the same time. So that's the society's responsibility. I hope you all understood all that responsibilities, because this virus has the possibility of attacking almost all the human beings, right? So from the data that we have right now, and some might say there's a clear difference if we compare the effects of the European societies and the Sri Lankan societies. There are some reasons that we can discuss as well. So some I will tell. It's sometimes the timing, the virus, when we get the outbreak here in Sri Lanka, we knew some data about the virus, so we knew how to protect ourselves. At the moment, we were already used to wearing masks, but Italy and those France and those areas were not ready for the virus. It was brand new for them. And the another thing is the heat, because Sri Lanka is a tropical country. We have direct sunlight throughout the year, and our open areas like surfaces are less prone to keep virus for a longer period of time because of that excess heat from the sun. And there's a one important fact that I have noticed last week. In a video, I have seen that a doctor from Italy talking about the vitamin D deficiency in the corona patients. He did like a research on some corona patients in his ICU, something like a 50 to 60 patients who have gone to severe conditions, and he found out that these people have low vitamin D, like low vitamin D amounts in their bodies. So vitamin D is something that you get from the sunlight, right? So, and you have to have not so dark skin as well. You have to have a brown skin to get the maximum vitamin D out of our skin with sunlight. So here in Sri Lanka, we have direct sunlight, we have brown skin, so we have the ability to create more and more vitamin D in our system. And we eat a lot of fish as well. There's an anomaly in Norway as well. In Norwegian countries, they have less corona positive patients going into acute conditions, because another study found out that they have high vitamin D concentrations in their bodies because they eat a lot of cod fish. So that's another interesting topic that I have came across while doing the research for this talk. And the other one is, of course, the healthcare that we have here in Sri Lanka. We have free healthcare in Sri Lanka, and people are not afraid to get sick here in Sri Lanka. Even though we get sick, we will call the authorities, we will call the ambulance, and we can go to the hospital. The hospital won't charge us a penny. That's a huge factor when it comes to battling a pandemic, because as you can see what happening in US, people are getting sick and they are afraid to go to hospital because of the hospital bill that they have to pay at the end of the treatment run. So people will stay at home and get more sick, and they will go beyond the point that the medical care can help them, and they will die eventually, sadly, inside their houses. But Sri Lanka, it's totally different. Even the patient can't reach any hospital. The hospital will reach the patient, and the hospital or the healthcare system, the military, police, we are doing a fantastic job in that point of in that region. We'll take care of our people so well, and people won't have to die in their homes at the moment. So it's something that we doing well in this pandemic situation. So society in that manner. So engineers, of course, the most important part of the talk. What can we do to face this enormous problem that we have in the world, in the country and in the world? So as the pioneers in a society, almost every society, engineers have been the pioneers. We have maybe the first person who found out about the fire or a wheel could have been the engineer of that small society. So we are the people who should help the others to find a solution. So I will like to reach out to you as another engineer, because I was able to do that because I had a friend, a doctor, and I had a chat with that person, and he conveys his information, and he said, okay, this is going to be a pandemic, and this will going to cause like a panic in the intensive care facilities of Sri Lanka. We are going to run out of ventilators. And we had this little discussion. And then I said, okay, can't we have like a solution? Then we had this discussion going on for a week, and we came up with a solution, a simple ventilator, which we can make with nothing. At least like all we need is like a wiper motor and like a mechanical ambu bag, and then some structure. That's it. So we came to that point because we had that discussion. Because as an engineer, without knowing anything about medicine, without knowing anything about patient care, without knowing anything about pandemics, I can't give answers, because to give an answer we have to know the problem well in the at the start. So I encourage you to have discussions, talk with your family, talk with your loved ones, talk with your friends, the doctors, the nurses, the health workers, the police, the army personals, anyone you can contact in your friend group, in your society group, and get to know their problems, get to know their difficulties, and try to find an answer, a well developed answer. Well, because you have the ability to do that. Computer engineers go out, do anything to help the society. I have seen a really good app that going on, that you don't have to use a pen and paper to write down your information. You have to just scan the QR and that's it. Fantastic. So like that, you have already done a lot, I know, but we can do more. That's what we do. We find answers, we solve problems. Let's do that one more time. Let's help the world as engineers. And I would like to thank you for listening so patiently, more than an hour, I think. And thank you so much for joining, and stay safe and be creative. Help the world. Thank you.